Hey everyone, welcome to Orb Creations, the show where I build an app, you get to see how I do it, and you get the source code in the description. Today we're building a snake game. I'm sure you're all pretty familiar with the snake game. You're a snake, and you use the arrow keys to move around and eat food. The food makes you long, and you have to try to not run into yourself or the walls. The game of Snake is set on a grid. This is a great setup for a game because we can use an array in our data model to represent the board and its XY coordinates. All of the logic that we need to implement in the game really just boils down to referencing positions in this XY grid. For example, moving the snake around, randomly placing the food, and collision logic are all just operations against the grid positioning. So, to start, let's create some simple markup to represent the HTML elements that make up the game. We'll have a container element to hold everything in place, and inside the container, we want to render the snake, the food, and also a grid. For the grid, we'll map over a board array. As you'll see later on, we don't technically need to render the entire grid, but doing so helps make the CSS a bit more consistent, so we'll do it here. A more polished version of the game probably won't need all these divs. Up top, we're going to define the board array. For now, we'll set the board to be a 20 by 20 grid. The main challenge here with CSS is to ensure the board is always a square, but is still responsive to window sizes. Since we have a 20 by 20 grid, we'll set the width of each square to 5%, which should fill out the entire width. To ensure that the height matches the width, we'll use a little padding trick. If we set padding bottom to 5%, the browser will calculate that padding based on the parent's width, which gives us the square shape that we want. Now, the square itself won't actually be filling that height, so we'll render a pseudo element to take up that space and give the board some background color. Now that the board is ready, let's dig into the real meat of this app, which is implementing the Gamestate. For Snake, there's only 2 pieces of state that need to be tracked, and everything else is a derived calculation from those 2 pieces of state. The first is the position of the snake, including its head and body, and the second is the position of the food. We'll set up an interface that defines the position state we're going to hold about both the snake and the food to be a JavaScript object with the XY coordinates as properties. Then, we'll create defaults for the snake and food positions. We'll start the snake in the same position in the middle of the board every time, but we'll use a function to generate the default for food because every time the food is eaten, we'll need to change the position again, so the function can be reused later. The snake's position is an array of position objects because we'll need to track the snake's entire body and display it for the user. The snake also gets progressively longer as it eats more food, so we need a way to track how long it is and where the extra length gets positioned. We'll also set up a JavaScript object which defines the bounds of the board. When the snake runs into any of the 4 walls, the game ends. So we'll want to be able to make comparisons of the snake's head position against the boundaries of the board. The logic for that looks like this. Basically, if the snake's head position exceeds the max bounds or is less than the minimum bounds, then the game is over. We also want to check if the snake has run into itself, and we can loop over the snake array to see if the head overlaps any of the body segments to check that. If there is an overlap, then we'll call the GameOver function. The GameOver function simply alerts the user that the game is over and resets the board for a new game. Finally, we'll need to write some logic to check whether the snake has eaten the food or not. To do this, we need to access both pieces of state and check for overlap. If there is overlap, we'll first unsubscribe from the inner state to prevent an infinite loop before appending an extra snake segment and resetting the food position to a new random point on the grid. You may have noticed that we've been writing our XY positions in hundreds of units. That's because we'll be using percentage units in CSS3 transforms to move the snake and position the food. In CSS3 transforms, percentage units are calculated as a proportion of the target's own dimensions. For example, translate x 100% means move to the right by an amount equal to the element's width. To ensure the snake stays on the game's grid, we're counting in hundreds of percentage points and using CSS3 transforms. This allows the movement in the game to remain performant. To actually render the food on the screen, we're going to style a div element as a yellow-colored square and position it according to the position in the game state. The getPositionStyle utility function will just take the XY coordinates as input from the game state and return a CSS transform that places the food in the right spot. For the snake, we'll do something similar. Instead of rendering only one square, though, we're going to render one square for each item in the snake array so that the snake's entire body can be displayed and positioned properly. We'll also color the snake green instead of yellow. That's it for the snake markup, but we have a bit of logic to write to allow the user to actually move the snake around using arrow keys. To start, let's create a variable to hold the delta for the snake. This JavaScript object will hold state about which direction the snake is traveling in. When the user presses the arrow keys, this object will update to reflect the new direction of travel for the snake. We'll also define a reactive variable to calculate how fast the snake moves. We'll be using a setTimeout call to periodically move the snake. As a result, this value is essentially the number of milliseconds to wait before moving the snake in the direction currently defined in the delta state. Usually, in the game of Snake, the snake gets faster and faster as it eats more food, so we'll divide by the length of the snake to decrease the amount of waiting time as the snake gets longer from more food. Next, we'll initialize the timer. On mount, we want to instantiate a timer which calls a moveSnake function after the amount of waiting time, which we defined earlier, has passed. To move the snake, we're simply going to update the snake's position array in the game state. We'll initialize a new array and loop through the previous array to modify its elements and add them to the new array. For the loop, we're going to loop through the snake from its tail to its head. To be honest, I'm not sure why. This is how I recorded it, and I do the voiceover after recording, so we're just going to roll with it. The logic would probably work fine if you loop through it normally. If the current segment of the snake is a head, we'll create a new head in the new array, which is incremented one block in the direction of the current delta. Remember, we're counting in units of 100. If the current segment is not the head, then we'll add the previous block to the new array. This is what creates the slithering effect and shows the snake moving around. Finally, we'll return the new position array for the snake and set another timeout so the snake can move continuously. The last bit of logic we need to implement is allowing the snake to change directions when the user presses the arrow keys. To do this, we'll use the Svelte onMount callback and attach a keyDown handler to the document. We'll also clean the handler up when the component unmounts. For example, when the user presses the up arrow, we want to move in the negative y direction, so we set the delta y property to -1. If the user pressed a key that isn't an arrow key, then we won't do anything. Now, When the user presses an arrow key, we want it to interrupt the normal cadence of the snake moving. Otherwise, there might be a delay between when the key is pressed and when the snake actually moves, since we're only ticking every few milliseconds. That would feel unpleasant and laggy. So instead, we're going to immediately cancel the existing timeout and call the move state function. The move snake function will reset the timeout so the snake can continue to move after the arrow key is pressed. And there you have it, a snake app. The app is currently hosted on Orb at snake.orbapps.com, link is in the description. All of the code that goes into this app is linked in the description. Be sure to check out these other videos on your screen right now. YouTube doesn't tell me ahead of time what they are, but I'm sure they're great. If you want to stay up to date on new apps we're building and coding tips and tricks, be sure to demolish that subscribe button and follow us everywhere else. Until next time, remember, Pythons live above sea level.